Talk now by Carina Haupt. It's going to be the basics of software publication. She is like an software engineering team lead, doing like lots of open source stuff for the DLR, the German Aerospace Center. Research center. She's done like lots of chaos. She's kind of like part of us for a while. She's given several talks. She's also heralded and stuff. And now she's going to talk like what to do with your code when you share it and how do you do that. What do you need to keep in mind? What do you do about like licenses and stuff? And with that, give up the applause for Carina.
So, welcome and thank you very much for the nice introduction. So, as you mentioned, my name is Carina, and I want to start with a really quick poll. So, who of you have already published some code, so put it out there on the internet? Show of hands. Okay, some. And who of you has not published something because he or she thought, okay, that's not good enough yet? Okay, roughly the same number. So today I want to give you an overview what is like the minimum you should do that other people are capable of reusing your code, of working with it, either using it, modifying, extending it, so the whole idea of open source. Because in reality, when you go to typical collaboration platforms like Github, there's a lot of code there, which is amazing, and some of them has great documentation, and you can go there and use it, and it's really nice usability. But there's also a lot of stuff you can't really use because there's no documentation or the wrong kind of, or there's no license or something like this. And I think we have so many amazing hackers and stuff in this community, but and there's so much great code coming out of it. But sometimes you can't use it in the end, and that's really making me sad. And that's why I wanted to give you an overview, so that we get more in the direction which is typical of open source. And you say, hey, yeah, can I use your software? And you say, yeah, it's here, just grab it, work with it, instead of going, oh no, my God, don't look at my messy code. Which is something I think a lot of you showed your hand that you know that, how this feels. And in my work, I work a lot with researchers, and they often talk to me and say, okay, I can't put it out there. I would have to optimize it. I have to make it perfect. I have to do this and that so that I can put it outside for others to show that I don't embarrass myself or my company or whatever. And in my opinion, that's not the case. There's a minimum you should fulfill so that you have that others are capable of using it, that are capable of reusing it, of modifying it, of working with it, of contributing. But it doesn't mean it has to be the perfect project for everybody. And so this talk should give you an idea about what is like the absolute minimum which you should do, that others are capable to do all of this. But also you don't have to spend all your time to make your code the perfect project for everybody. Because you might not have the time and energy to do so. And until you put your stuff out there, you often even don't know how many people will use it and for what, or what they are needed from you. So now I talked about that it helps others to work with your stuff, what I want to show you. But in my opinion, or in my experience, it also helps you. When you come back like 6 months or just even 3 weeks later and run your software, it can be that you don't exactly remember how something was done or how you executed. Okay, get some positive feedback here, nice. So this is not only for others, but it's also for you. So I want to give you an overview about typical good practices. I'm always talking about good practices, not best practices, because in the end, it depends on your project and your context, what is best for you. So there's some recommendations which are good. You might follow them, you might want to, but in the end, you always have to adapt everything you do to your specific project context. This talk is based on a training we give, which is normally nearly 2 half days or a little more. So now I have 45 minutes, so you can imagine it's really just the essence. And it's reduced to like the most basic things. In our training, we always have this small example. As I mentioned, I work in research with researchers, so we have and I'm from the Aerospace Center, so obviously our example has to be with astronauts. So the idea is that we have a small script which somebody wrote. It doesn't matter, it can just be any kind of code, and which has some dependencies, it creates some output, and yeah, in this scenario, I created it part of my job. And I want to make it as easy to reuse for others as possible. And there's like 5 steps you can follow. And originally, I have 6 steps because this is focused for research, whereas there's also a publication and citation step. But I'm omitting it here. Perhaps if we have some time, the question or so, we can go into this if somebody's interested. But it's 5 easy steps. The first one is put your code on a version control. This seems like basic, but still a lot of stuff, especially in research, is handed around in tarballs. You can't imagine how this is not dying out. The second one is to make sure that your code is in a shareable state so that you can bring it. So, of course, it has to be a little bit clean up. Add essential documentation, add license, and in the end, release your code, obviously. So, meaning the process of releasing. The first 3 steps are essential aspects which you should do anyway. It doesn't matter if you want to publish it or not. That's something which is just to do so proper software development, software engineering. Even if you don't give it to external people. Step 4 and 5 is more like if you really want to hand it out, but nonetheless, you should think about it in advance, because especially licensing is an issue which is easy to target or address at the beginning, but really hard to address at the end of your project. So let's start with version control. So obviously, you should take everything you need and put it into at least something like a Git repository, which can be at the beginning locally, even with a backup. I mean, most of you will start with a collaboration platform, typically something like Github or GitLab, so this is great. But the minimum can be even a local Git is fine with a backup. But the interesting part is not that I'm telling you to use Git, but what should go into. And this is the first thing where, in my experience, even on GitHub, a lot of projects lack stuff. So you need really everything in the project which makes your project usable. This obviously covers the source code, but also things like documentation, build script, test cases, configuration files, input data. Is a little bit debatable, but small examples should be there, because nothing is better documentation as an input file, like how should the input look like. You should avoid certain things, which you also find a lot, like third-party libraries, generated binaries. And if you have to work with big files, you still can have them in your Git repository, but because there's special cool tools like GitLFS, GitAnnex, DataLad, and because we're from research, there's research data management, publication repositories, because in research you often work with real big data sets. And again, this seems like basic stuff, but in the end you really have to think, is this working out? And the detail, what has to go into your Git repository, it depends on the type of product you have. For some, it makes sense to have the input data, for others not, or some output as an example. So think about what should go in there and use these nifty small things from Git, like git ignore files, to allow you to prevent also you or others to commit stuff into the Git repository which shouldn't go in there. And next to have like certain files which you often find in there, there's also obviously some security-related things where you should be sure, like SSH keys or something, that they don't get in. Yeah. Quick one, step 1. Let's go to step 2, bring it in a shareable state. There we get a little bit more specific. So make sure others can run your code. So we all know this comic or this typical thing, it runs on my machine. This is nice, but obviously this is not helping. So check your code that you have no dependencies on the internal resources. This means servers, storage, but also licensed software you're using. This is a big problem in research, that you often have some base license stuff, and it's often not really well declared. So try to get that out. It's also basics like no absolute path, and but also to clearly state the dependencies you have, and provide required build or installation scripts. Our example here was Python code, so we recommend pip tools and poetry because they are crucial aspects of reproducibility so that others can get the same results that you have. So again, look at stuff like that, then organize your files in a suitable directory structure. This sounds so basic, but it's making such a big difference. There's great templates, for example, the Python application layouts or good data practices, how you could structure your code. And I started doing this stuff at the very beginning of every project I have. I have like a template. There's even frameworks for stuff like that, like Cookie Cutter or something, and they allow you to have a nice structure and all the files in there and the folders which you need, so you don't have to start like with a blank slate. I normally first create all my structure and all these things I need, and then I start before I write my first line of code, because it feels like a real software project before I start writing code. And this is on the one hand a nice feeling, because you work on something, you have the feeling, and not like on this random code snippet somewhere around. But it's also really helpful because I open a project and I see the structure, I directly know where can I find the code, where can I find the tests, where can I find what. And if it is there, because if it's this typical structure, I can get really quickly feeling around. And obviously, do not share sensitive data. I already mentioned that. It's really fun when you go to GitHub and something and search for SSH keys. In the past, there was like thousands and millions. And, but also other stuff like passwords and user accounts and internal IP addresses. You get really much. Yeah, GitLeaks is there, a helpful resource. But also orientate on your standards. Again, I mentioned I'm not a big fan of best practices because different communities have different typical structures. So it's different if you have a structure in Python versus if you have it in Java or C++ or C. But it's not only this. It's also that in certain domains or communities, a specific structure, when you work with a specific framework or so, is typical, so you should go with that. And this is exactly what I meant, that you don't have this one perfect, like this is how you do it, but you have to look at the context and where you move in. And this is really important for me, that you do it in a way that the people who will most likely will work with it will understand it, because they are used that it's done like that in this community. But this was more about structure and about like general input, but there's also like the understandability of your code. So if we look into your code file, into the source code, it's all about readable code. And again, this is something a lot of people don't pay too much attention on, because for me, consistent and light code layout, it's like if I read a text or a magazine. If I just have bulk text, it's hard to read, but it's well structured. If there's a layout behind it, if it's a little bit light, then you can read it really quickly and easily. And normally in my training, they show like a bad version and a good version and say, okay, can you have an idea about what's in this code? And in my experience, it's like with the one, everybody's struggling and saying, okay, I roughly have an idea what it's rough about. And the other one, where you have nice functions with good names, where you have code comments on the right places, but not too many. If it's lightly structured, following typical conventions like PEP 8 or something, then it's really easy to read and people can really grasp how everything is working. And for me, it's normally you have in Python somewhere and your main function or something, or where you then just run the your main function. And in that, I always say this should be able to read it like a small story, that I know, okay, this script or this software is doing this and that and that, and this, especially for small scripts, you can really read it like a short story. And if I need the information, I go into the functions. So this should how it would work. And so this is a typical clean code stuff we recommend here. And the nice thing is you don't have to do all of this manually and check it or implement it, because there's nice tools like linters, which you can have in your automatization. We will check for you if you follow these guidelines, or even you can like let them format your code for you, that you have a starting point, and then the best idea is to just go along and follow it. A recommendation I always give is read out the code others for inspiration. Not only how have they done it, is it great code, then it's great, then you can learn from them, like do it similarly. But also if you read bad code, you realize what is the issue with it and how you could solve it, how this could be better. And I also recommend to do pair programming, because then you'll have to explain at the same time, like when you write your code and you feel like, okay, this is something I needed to explain, so perhaps I should have a comment for this. And obviously, not always there's a second person for you. Then just use your rubber duck and go to the nice system of rubber ducking to explain the code just to the duck, and it helps often a lot to figure out where did you need to lean in on the explanation. So this means this is a piece of code you either have to rework or perhaps add some comments. Testing. Who likes to write tests? Okay, I don't believe half of you. No. If you know how to write tests and you know the advantages of them, you start to like writing code. That's fine. And writing tests. Because often people say, OK, I need to test my code. They think about, I need to write tests for everything. If you do this, great. But if not, start small. Start with one test who's just running the whole thing. I know it breaks a lot, but at least it breaks and you get a notification. And then whenever something breaks, you write a test for that. And so it works and grows your test base. And so tests offer a good starting point to help to also make your code understandable, because if I can look into a test how something is tested, I can also understand how it's used and what it should do. And so automated tests work as an executable documentation. I can read it, I can understand how to execute it, because this is how it's done in the test. And it helps you also, linters, as I said, like flag-eyed or black, help also you to find your poor code snippets, which you can improve. And last, it's also when you start with writing tests, the step to starting doing automatization is not far, because having then a small CI script or something, or GitHub Actions, or CI/CD on GitLab, whatever, can help you with your automatization efforts. And then you execute your tests automatically. Whenever you commit or something, you don't have to think about it manually. And then you get some feedback if you change something. And this also increases the trust you have in your code, and especially the fear of doing changes. So this is something I learned a lot from researchers. They say, oh, it's working, but I hate changing some things. They're really afraid. You can see the fear in their eyes when it's like, can you add a new feature? I have to change the code base, but it's working currently. I'm like, you don't have tests, right? Yes. So whenever we work with them and we improve their code and we start using testing, the first thing I often learn is it's not that they break things, but they're not afraid to do so because they know it then directly, and not like weeks later when somebody says, OK, this looks wrong. This result looks wrong. And then they figured out, oh, I broke something weeks ago. So it's about getting comfortable to also have failures, to break your code, but getting this info. So this is helpful for others, but also for yourself to get more comfy with your code. Next step, documentation. Again, who likes to write documentation? Go on. OK, that's really few. And this is something which is also reflect. I mean, we have with GitHub and stuff, they have these great things, or GitLab, we have this great README files which are directly rendered. It's so amazing. And then you go there and there's like one sentence in there. Or, so how does good documentation look like? From our example, I brought this, and I think it's a nice entry point, because you see this is what we get out. So without reading it in a thing, you can see this might be the output, how it would look like, the graphs. You get some information where the data is from, how to run the scripts, and so on. It's also a typical structure we recommend, which is to add the software name. I'm still out of making a statistic on GitHub how many projects don't mention in the README the software name. especially if it's a cryptic short form and you don't know what it's doing. And that's the second thing, the purpose in 2 or 3 sentences. And it's really amazing how much stuff is out there where you have all the other things like how to install it, how to use it, how to contribute. There's a license, but it's not written what it's doing. There's a name, you have a rough idea, but you don't know really what it's about. And I'm like, how do you miss that? And it's often because you're so much into your project that you forget to write down what's the purpose, and even better, what's not. So it's really helpful often to say, this is what I achieved, this is what I'm doing, this is what I want to do with this, or what I'm using this for, and this is what I don't want to do with it. And so this is also the point where everybody who says, oh, I have to, this is not good enough, I just wrote this as a proof of concept or something, and people say, yeah, I have to make a real project out of it, I don't have the time, so it's sitting on my desk or my laptop, and it will be gone one time. Because in the purpose, you can also write, like, this is a proof of concept. And if it's in there, everybody knows what to expect. Nobody expects then the perfect modular and configurable code or something, because it's a proof of concept. So use this possibility to make expectation handling. So write down what this is for, what is the expectation which people can have when they use it, and then it's fine. And people are happy if they find something and they know, okay, this is just something somebody threw together, but perhaps there's still something valuable in it for me. And but with the structure, you have a good starting point. Sorry. But there's some more tips I have. The first thing is think about your target group. So for whom are you writing this kind of documentation? Typical perspectives, which we know are users, contributors, developers, or perhaps administrations. For users, you need information about installation and how to use it, perhaps some tutorials or how they can get support. For contributors, you need contribution guidelines, so how should they contribute, like should they create an issue, a fork, or can they perhaps directly commit to your branches, which I don't recommend, but you want perhaps give them a technical overview. And a lot of projects, this is all mixed together and people get confused. So users get afraid if they see a technical overview. Developers, if they miss it or get like just tutorials, are like, yeah, but I want to change something. So try to separate that. But obviously, not everything is going in one of these directions or in one of these categories. So sometimes it's necessary for both. And that's why there's often more files than the README. The README is like the minimum, it's like the project front page. Everything which is important for this project should be written in there or linked from there. But there's typical other files you can use. It's a contributing file where you have the contribution guidelines in, the code of conduct about communication rules, which I think is also important for projects. Like we want to have because you can also do expectation handling, like you can ask nicely for a new feature, but you might not get an answer because this is a side project of me. So you can write something like that, and then it perhaps doesn't get in a nasty, you never ask you never implement what I'm asking for, something fight. Then obviously the license file for license information. We come to this topic in a minute. And the change log for major changes, and also a citation file. This is something especially from research where you can have citation metadata, because we are in the process of making software also research output, so that we are not just can cite our papers, but also cite our software project, which is kind of a change happening in this field, which is nice. And today we have so nice solutions to do all of this easily, directly in collaboration platforms like GitHub and GitLab by using Markdown or other markup languages, which are easy to write this documentation. But also, if you have typical documentation tools which are used in certain communities or programming languages, for example, like Sphinx or whatever, go with that. In the end, it's important that you write it in a good way and that it's close to your code. So I'm a big fan of having it for smaller things directly with me in the repository, because then if you change something on your code, you might directly change it in the documentation and not have it somewhere else. One thing about writing good documentation, which I like, is that the best documentation is the one which is just good enough. Because if it's good enough, it's good enough. People can use it and they can fulfill their stuff. But if you're over this point, then you have written additional documentation. And what's the worst kind of documentation? Outdated documentation. When you think there's everything written down, but it's not true. You find something, but it's not matching up. And that's sometimes even worse than none, because it gets you completely confused and you're not sure in which state is the software when the documentation is out. Is it really doing this? Is this wrong, or is the documentation wrong? So it's something which in the end was really researched, and people say, okay, just good enough is like the perfect spot for documentation, but it's nearly impossible to target it. In the best case, you're just a bit above, but this is what you should aim for, so that you don't have so much to maintain, because maintaining documentation is a hard task. And as we saw, not a lot of people like writing, like 2 or 3, or perhaps you have, people can ask you. But most people don't like to write documentation, so maintaining it is often even more annoying. So the minimum I recommend is always go with README, have their all important stuff either written into it or linked. But think about what is your target group, who you're writing it for, and adapt the content and the language, or use several files and make at the beginning clear who this current documentation is targeted for. Okay, let's come to the topic of software licensing. Software licensing is something which I'm a big fan of. I don't know exactly why, because it seems like a dry topic. But in the end, it's something so fundamental. So some basics. In Germany, you have the copyright in a way that software is protected by copyright. The copyright protects the expression of an idea, which you then put into code. And the copyright grants exclusive rights to the copyright holder. Meaning, if I'm creating software, it's mine. Just like when I draw a picture or write a text. But so I have certain rights. So, for example, I have the right to be named. So I can say this is done by Carina, and I have this right that I can write it down. But there's also that I can decide what happens with this. Who is allowed to use it? Who is allowed to distribute it or something? All these rights I have at the beginning. Except when I work for somebody. Because normally when you work for somebody, you sign a contract, and then your employee has most of the exclusive rights, which means they can decide whatever to do. Normally, they can decide whatever they want to do with the software, except one thing: you keep the name, the right to be named. In German, it's Urheberrecht. So you still have. They can say, okay, this is done by DLR, but by Carina Haupt. So I'm still allowed to, or can say, I want to be the author and I want to be named as the author, and this is a right I can't give away. So this will be a little bit important later. Sorry. But also, everybody who contributes to my code also becomes a copyright holder. Meaning, if I put something out there, putting it open source, and somebody else is contributing too, they have all the same rights. They are co-copyright holders, but they have the same rights. This is important when I want to license something. So everybody who has contributed has to agree. Then if we want to say, give certain rights to somebody, this means we want to put it open source, we want to sell it commercially or something. It doesn't matter. Everything which is about licenses in that moment has to be decided of all the copyright holders. And this can be tricky, so meaning when you put stuff out there and a certain license and other people contribute too, you have to have the agreement of everybody else so that you can change the license, because they have all the same rights. And if it's other people who've contributed who have employee contact, so they did this in their work time, it's their bosses or their companies who have those rights. Meaning, if I work together with other research institutes, it happens really quickly that 10 different research institutes have rights. And then we want to decide which license to add on it, and that's kind of a tricky situation, because then you have 10 legal teams, and it can take years. So the idea is decide early on which license to use. And then everything's under this license, and as long as you stay there, great. There's also some things like CLA's contributor license agreements, where you can hand your exclusive rights to somebody, like to a certain entity. This is often done in open source, where you have like an open source foundation or something, where you say every contributor give their rights to them, and they can decide when the license needs to be changed or something. But this it means a lot of legal work, because officially you have to have a contract. I've seen in the web a lot that you click this rights away. That's legally binding in Germany. You have to sign it, to write a letter, or fax it, obviously, because this is a legal thing which is still allowed. Okay, so this as a little bit background, but let's now look into software licenses. So which type of licenses exist? I would expect most of you know the typical type, like free and open source software, public domain, and proprietary. That's the first distinction. Proprietary, a lot of people think it means commercial, but that's not true. Proprietary just means it's not public domain and not free and open source. Everything else, it doesn't need to be commercial, is proprietary. Free and open source means, has a definition which says you have the rights to use the software, to modify it, to distribute it. You might have also some obligations to fulfill, and that depends. That's why we have copyleft and permissive types of open source licenses. But on the first hand, that's like the rights which free and open source licenses hand to you. Public domain is a little bit special, because they say you can do whatever. So it's really meant that you give something to the public. It's not yours anymore. In Germany, legally, this is not possible, because, as I mentioned, you can't give the way that you have the right to be named. You can't give that away. It's something not transferable. So public domain as a legal construct doesn't exist really in Germany, which is interesting. But you can use it anyway, because in the end it's about intent. And you showed the intent with that you wanted to give it to anybody. So if you later would sue, they would say, yeah, but you said it's public. Everyone can do whatever. So yeah, just an interesting side fact. But let's go back to the free and open source software licenses, because that's what we're interested in, and that's the difference between copyleft and permissive. A lot of people are kind of confused about what is what. But in the end, behind it is two different mindsets. Copyleft says the word is evil. This is like their slogan. But in the end, the mindset says everything which is free should stay free, and everything which is built upon something which is free should also be free. Sounds great. Permissive, on the other hand, says everything which is free can be used for whatever. So you should have the freedom to use everything which is freely available in any way you want. The typical best-known examples for permissive are Apache, BSD, MIT licenses, and copyleft, the most famous one, is the GPL. Copyleft licenses mean they are effective, because they say when something is built upon something free, it has to be free itself. Meaning, if you use copyleft code in your project, the whole project has to be also under copyleft license, under the same copyleft license. And this is where it gets complicated really fast. I brought this, So this brings with it the topic of license incompatibilities, because it's an easy construct to imagine. If you use two different part of codes which are both on a copyleft license, and they both say the generated software has to be under their license afterwards, so the software as a whole, it's not possible to fulfill both things at the same time. Now, normally somebody says there's something like dual licensing, but dual licensing just means you publish it under two licenses, but each software which you publish under that third license has to be inspected on their own. And if you look at it on their own, they will always disregard one of the licenses. So when you use two parts of copyleft license code in your code, it can happen really quickly that you have something which I often call impossible software. You can't give it away. You can use it privately, because there's something like internal use or private use. So you can use it privately for yourself, but as soon as you want to hand it to somebody, you can't, because you will definitely disregard one of the licenses. Interesting fact is that private use is restricted to juristical organization, meaning in DLR, it means all of DLR, and we're like 10,000 people. So when I build something, I can give it to all these 10,000 people, but not one person outside of it. So this is why it's important that you make sure at the beginning that under which license code is which you use, so that you don't get in trouble later. But more important is that you have to check that all your code is under any license. I had this nice discussion just some weeks ago where somebody said, yeah, we use this code we found on GitHub. And I'm like, yeah, great. What licenses? Oh, it's great. There's no license, so we can just use it. And I'm like, no, that's not how it works. Just because something is out there, you can't take it. I mean, just because stuff is standing around here, you can't take it. It's still illegal, it's still stealing. And that's the same for code. So just because it's there, nobody's paying attention, you could say, yeah, no, that's not the case. If there's no license, you can't use it. And this is a big issue. This is why GitHub and stuff have add a license or something, so that you at least put something to it. Because if you don't cover it, others are not allowed to use it. They can look at it, but that's kind of it. So this license slide is confusing, and I won't go into detail. I brought it because it's when you combine modules under different licenses, it gets complicated. And at the end, what you see here is that on the right, when you have a permissive component and your own component on the very left, you can see that you normally can do whatever you want. So it gets orange, so it means like you can do whatever you want with it. You can put it into a commercial project or something. If you have something with a strong copy left, that's here on the left, the bright green, like GPL, you mainly end up with GPL. There's exceptions. I don't want to go into detail now because we're running out of time for that. And I can have an hour talk about just this slide. But there's something in between, which is called the LGPL, the lesser GPL. Some people think it's like lesser strict, but they meant it like lesser good. Version of the GPL, which they introduced exactly for libraries because they have like this mixed mindset. They say everything what is free should stay free. So they cap that, meaning if you change code in the library, it has to be under the same license. But if you use it as is in a piece of code inside, then you're also allowed to put it in commercial software. So if you don't change something, if it's free, it has to stay free, but if you build something on it, that's fine, you can do whatever. Again, there's also some details, like people have to be able to exchange this library by their own version, so you have on a technical level some restrictions. It depends how tricky this is deeply on the language and the frameworks you use, but I can't go into detail here again. We can stay an hour of this. I just wanted to brought it to you to show that it gets complicated. And there was a study some years ago which covered like that most developers are firm with one open source license, but as soon as two, it's like less than 10% know what to do with it. And so that's what my message is here is take care when combining code under different licenses. And I talked now a bit about the theory behind it, but I want to go back to what to do with this with your project, because now I scared you away about licensing, so now it's complicated. But this is not the idea. What you need to do is, if you want to publish your license, is to choose a license. You have to consider strategical implications. So do you go with a permissive one, so everybody can use it, but they can use it also in commercial tools? Or do you go with a copyleft, like GPL one, which means others can't use it in their commercial tools, and perhaps it would be just a tiny bit, and they would contribute back. So you have to think about what your goals and your values are. But you also have to check with all the third-party dependencies you used, which licenses they have, and which restrictions this inflicts on your code. Then if you, like me, work for somebody, you have to ask your boss for permission. You can't just publish, because they have the exclusive rights, so they have to decide in the end and agree which license to pick. And then you have to add the copyright holder license information everywhere. Not just once, I'll show you in a minute. If you're interested in top of this topic, I wrote with some colleagues DLR open source brochure. I will upload the slides later. It's in German only, but it provides further detailed information. It's all information you also find in the web, but we checked a lot of the things because in the web there's also a lot of wrong information. And if you work somewhere, find out if there's any organizational process or ask for legal advice if you're unsure. It's really annoying to talk about lawyers with licenses because they're always, yeah, in the end, and there's always this practical side, but in the end, try to get help there because it's a big topic, it's a complicated topic, and you might not have to deal with this alone. Okay, so let's go to example. What have we done? There's nice tools like chooselicense.com which help you to select where you will get asked some questions and you will get a suggestion which licenses you can use. For us, we came up with the MIT license, so we had to check does it work with the dependencies, what is with non-code artifacts, because they should be licensed as well. So what we did, for example, is we said the copyright holder is a German Aerospace Center. As mentioned, we wrote it, so we have to give it there. We decided the source code should be under MIT, but for example, the data set we used came from Wikidata, and they said it's under CC0. Our own documentation and the plots we create, we want to have under CC BY because the Creative Commons licenses are much, much better used than MIT or something for everything which is not software code. And everything else, like I would say that's a catch-all phrase, like all the insignificant files which are also there are CC0, public domain, do whatever you want with that. So now my boss is fine with it, but how do I annotate it correctly? And I mentioned that this kind of information has to be on all the files. What you see most, and also like GitHub or tools, is say they add one license file, like, and then the MIT license text in there, and that's it. But as you saw, I decided to go with a whole bunch of licenses for different parts of my software project. So this has to look a little bit different. So you have to add license files, because we have now several licenses to go, and note with copyright holders. Again, this could be also different people. And there's a nice tool which can help you, which is called Reuse. I think it was developed by the Free Software Foundation. And this, you can say, OK, this file should be under this license, and it will create you all the nice license files. And will also not add the whole license tags to all the places, but work with something which is called SPDX tags, which can also be read by computers. And it's a nice helper tool which will structure you. So it's a whole specification, but it has this nice tool which helps you to make your code nice. And yeah, you find tutorial, FAQ, specification, so on. It's command line based. It looked like that. It changed the headers automatically. When you say something like copyright holder should be German Aerospace Center, license MIT, and then go to the code folder and run it on everything there. And then I will have down there these nice short SPDX tags where I just have this information, and in my license folder I have somewhere the MIT license, and that's it. Okay. So let's sum up. Software licenses grant rights to others, but also come with obligations. You might have to put something on a certain licenses, or you have to add information. Make sure that every code you use is covered by a license. So this is a take-home message. The next one is take care when combining code under different licenses. It gets complicated really fast. And then make sure you publish your software using a clear license, meaning make it state for every file like how this is added. And the nice thing is you can add it either like these headers, but even if you have image files, you just have a file next to it like output/image.png.license, and in that is the header, and so everybody knows exactly which license is valuable for which project. And reuse is really a great specification and helpful. So this was a lot about licenses. It's an important topic, but let's come to the last step, which is a release. To create the release. And what is a release? The release is a specific working software version. So there's different release number schemes. The most used ones is like 0, so the semantic one, so 1.0.1. which is indicating how you count up which type of change if it was a minor change, a major change, or a breaking change. Or you can go with dates, something I like in research, because then at least we have regularly an update, because everybody else is always, is this now a major change, and do we count up? And there's like, okay, we just do one every 3 months, and it doesn't matter if there are really changes or not. It's 3 months, so we do the new version, which is good, because then you have at least a stable version from the last time. The release package, which should be created in a release, can be used by the user to install and use the release software. And so the release should contain the code, obviously, as well as the documentation. And simple form you can do is a snapshot of your source code repository packed in a zip file. Obviously, there's better solutions. You can have Git tags or something. And important changes between releases are documented in a changelog. Note it's not just a commit history. It's extracting like the main things in really short sentences. The best is to have like current changes section, so you can write it while you do it, and for the next one you have it ready. So you know always like what's the current changes, and then when you create a new release, you just change the heading in the changelog, and that's it. What do you have to do to prepare your code? Okay, define the release number, update the documentation, and perhaps if you have citation information or something, update this metadata. Check your code that it's really working. Run all the tests again, stuff like that, and then publish and achieve the results. For example, mark the release in the source code repository using a tag, create this release package. How this exactly look like depends on the programming language framework. As I said, worst case, just do a zip file, that's fine too, and archive it somewhere. We did this on GitHub. We checked everything, we did all the steps before, and then we created our release 1.0.0 as a Git tag. So there was we on the end. What have we done? We went through these 5 steps. It got a little bit more complicated over the time. We started with putting everything in a version control, but not just putting it, but deciding what should go in there and what not. Then make a good structure for the project, bring the clean code in a clean state so that it's shareable, add the essential documentation, keeping in mind who our target audience is. We talked about licenses a lot. And about that, it's a complicated topic, but you need to add the license information everywhere. And last, that you also don't forget to release your code in a nice release package, which can be used by others, that they know this is a stable version I can use, which should be running, and I can use whatever's in the repository, but this is the last stable one. And with this, I'm at the end of my talk. And thank you very much for your attention. And if you have any questions, I'm happy to answer.
Thanks a lot for this very packed talk. It feels like I want to spend it through 3-4 hours or something, but we can't because time is limited. However, we do have like 12 minutes for Q&A. Are there questions? I'm sure there are questions. We have Eska going around with a microphone. I would say, yeah, in the middle somewhere.
So is adding the license for every file really necessary all the time, or just if you have mixed licenses for different types of files?
The most licenses, so open source license state in text that the license information have to be added to every file. So in this case, yes, it's necessary. In reality, nearly nobody does it. Or it used to be typical. So when you remember, when you find old code, you see that the whole GPL text can be on the top of a file, like hidden in a comment away. Now with the SPDX text, it's nicer. But so officially, it needs to be done. Minimum is have the license file, because then your intent is clear. But legally, if you want to do it properly, it has to be in any file. But as I said, reuse is a great tool to help you. Just set it up once and then you're done.
One question behind you, and after that, I guess we go to the Signal Angel.
Can you recommend a tool for how to get a setup script? Because a lot of people just do apt-get install in a shell file, and I don't have apt on my system because I'm in another distro. Is there any standard, especially for C stuff?
I'm really not well with C, so I can give you not really a recommendation there. again, this is something where I would say it depends on your target group what I would recommend to do. I think it can be totally fine to say like use apt. So for Python, it's always that it's just a requirement 60 and say use pip. So you have to deal with figuring that out. But what I also recommend is for each dependency which you have, you should also link to their website. So at least you can go then to their installation site. It's not an automatic process then. But to be honest, if you decide to go on a little bit strange way, then you have perhaps to deal with these consequences. In the past, it was like the typical Monday. I need to get everything from source and compile it. That's the old style. But yeah, so this is something at least I think in the documentation go so far to at least link to the proper sites where you can get it, also the right version, so that people at least that don't start Googling and figure out which version to need or not finding it anymore or something like that. So that's the minimum I could say. Sorry.
The question from the internet.
Yes, the internet wants to know if you have any tips on cleaning metadata easily from versioning systems. For example, if you wish to publish the source code and a few selected branches, but not the commit timestamps and the authors.
Modifying your history is always a not recommended move because you can really screw up your Git really easily. You can squash stuff, but then people can't follow what you did. So I don't really have a good recommendation there. In my case, I always say when you start working, think one day you will publish it. So start writing your your commit messages and stuff in a way like, this will be done one day. But in the end, what we have done in the past, in reality, is squash it and then just publish it in that version. Then you don't have this info, but sometimes we then at least extract the commit messages and put them together or something. It's not really helpful, it's not good style, but sometimes we had to do this also because we never were sure what was committed in there in between by some students or so, if there was some security breach stuff, so we had to just squash everything and they just got the newest version. But it's not good style. So no, sorry.
More questions? I'm seeing like one hand in the very back and okay, afterwards one in the front.
Hi, so what kind of minimal commitment do you expect from a person that decides to go public, like maintaining the public repository, answering feedback, continue maintaining it?
The minimum? The minimum is to state what you're comfortable doing. So it can be, I put this out there and I'm not answering any question, it's fine, but state that. This is like the minimum I expect. And if you are fine with answering some questions, then again, go to state that. Like, I'm doing this as a side project, as a hobby. It may take weeks to answer. I might not answer. You say, but I will answer definitely at one time. Just state it as good as you can. And also add something like, it might for one or certain times be different, but at least state it, then other people can know what to expect. And I think expectation handling or management is a really important factor which is neglected a lot. So, yeah.
Yeah, thanks for the great talk. About licenses, is there a reason why you choose MIT or why you didn't choose a CC license for the code? Is it an option to have a CC license for the code?
Technically you can, but it's not recommended at all because CC licenses are very well written for files, for images or something, but not really for source code where it's about modification and stuff. So public domain works, CC0, but everything after gets complicated because CC BY is how do you make it when you have a lot of different parts? You can mark it. This one was from this person, but when it's changed, it gets really complicated really fast. That's why I always say use the Creative Commons for the images and documents and so. This is what they were written for, and use the software licenses for the source code because that's what they're written for. And yeah, there's a whole story like how it gets complicated really fast. And to be honest, it's a big problem that a long time, I think it's not the case anymore, but Stack Overflow answers were a lot of time under CC BY, which there's a whole thread you can write, which you can read up on, like how this gets messy and complicated if you want to do it properly. Most people just copy it and don't cite, so, but yeah. Again, this is not officially something you should do. Yeah.
Yeah. Thank you for the cool talk. You mentioned that as a contributor, you have the right to be named, and especially in Germany, you can sign that right away. Does that mean that every contributor to my project has the right to be named in the license file? So, for example, if you have copyright 2024 and then the name, because I've seen a lot of projects that they just put copyright, then the year, and then project name contributors, and not every single name. Is this legally required?
You have the right to be named, but you don't have to say I need to. What I recommend normally is to have authors TXT. So it doesn't need to be matched like this person did this change or something. In the past, it was common to have a lot of names. Everybody who modified a file added their name to that file. But to be honest, it got a little bit, with projects with thousands of source code files today, it gets cumbersome to add yourself to all these files alone. But add your once to the authors file is nice. Then you're listed there, and that's fine. So, and with this, it's fulfilled the right. So you don't have to target it everywhere. And if somebody says, I don't want to be mentioned, they can't waive the right away. But when they later would say and said, oh, I contributed once, I want to be named, you can't say, you're not able to say no. But if they don't add themselves, then it's also not a legal problem in that case. Because, yeah. When they would sue, you would say, yeah, then just add yourself, or I just add you, fine, done. I never said you can't, so you just didn't do it. So it's often in the contribution guide that it's written with your first contribution, add yourself to the author's TXT, or the contributor's MD, or whatever, and then this is handled. And for the copyright text, what you write in there, even with the year, it's not legally defined what has to be in there. That's a little bit, it should be good identifiable. Who has, normally it's used for who has the extension rights. So like, who do I have to ask if I want to relicense this or something like that? Who's this entity? And the year, it's written a lot behind it, but again, no legal construct that you need to do this. Yeah.
2 more minutes for questions. Do we have more questions? Do I see, well, one hand in the very front? I guess that's the last one. Unless it's very short.
Yes. So you were talking about visualizing the documentation through the Markdown. Is there some other ways to do it?
Yeah, sure. So there's strings, there's Java docs, there's like, depending on the programming language and what. So Markdown is the easiest choice to go today. So I recommend going with that because it's directly rendered. But it depends on the community you're working in and what's there the standard or in the programming language. It may also change over time because when it's a small thing, it might be fine to do it Markdown. If you have really much tutorials and so, then you go to something like read the docs and run it there or something. So then there's definitely different approaches to go later. It's just like the minimum and easiest way is this one.
We would have like one question from the internet. I guess that's the last one.
Thanks. The internet wants to know, for example, in the case that there is already an existing software, some tool, and in my project I'm adjusting the tool, adding new sub-functionality, so I have a software alternative. How is there a possibility to reference this as a software alternative, not as a dependency?
So when you're building on something, I would add that always as a description, like this is built on or based on this and that. I would add it in the documentation. And it depends on also the type of license the original code is under one. There's anyway some obligations you have to fulfill or some requirements, like normally you have to add the license header they had and state where it's from. And it's good style to say this is based on this software. Again, with this new emerging thing of software citation, there would be an even more proper way. But describing this is like a whole new further thing. So last minute, so.
Yeah, I think we are kind of at the end. So thanks a lot, Carina, for this talk. That was really good. Please give a round of applause to Carina.
And thanks so much. And if anybody's improving one of their software projects just a tiny bit because of this talk, I would be really, really happy.